Hello, and welcome to the Future of Being Human Unplugged. So, given this weekend's events around OpenAI and its former CEO, Sam Altman, the unplugged bit today feels rather appropriate as we're talking about AI. However, rather than focusing on these events, I have two fantastic guests joining me today to look a little further forward than the present and to explore the possible future symbiotic relationships with artificial intelligence that might arise. So my name's Andrew Maynard, and I'm a professor of advanced technology transitions at Arizona State University. I'm also director of ASU's Future of Being Human initiative. Before I introduce today's two guests, I do want to do a bit of scene setting. So this past year has been a transformative one in every sense, I think, in the field of AI, to the extent that topics that were considered fringy or completely in the realm of science fiction just a short while ago are now being talked about in the mainstream and by leading scientists. These conversations include the accelerating capabilities of artificial intelligence, the possible emergence of artificial general intelligence, or AGI, and even the idea that machines might develop consciousness and awareness, as we discussed in the previous episode of Unplugged. And amongst these, there's the intriguing idea that we might be getting close to a point where humans and machines begin to work together, not in relationships where humans call all the shots, but ones where machines have agency, autonomy, and choice. This mere possibility takes us out of the realm of how AIs are built and into the realms of cooperation science and even evolutionary biology as we explore what such symbiotic relationships might mean, which is why I'm joined today by two amazing experts who are leaders in their field in both of these areas. Let me just bring them onto screen. So first of all, we have Professor Athena Aktipis. Athena is an associate professor in the Department of Psychology at Arizona State University. She's also the co-director of the Cooperation Science Network and the Human Generosity Project. Athena studies cooperation across multiple systems, which range from human sharing to cancer and even to kombucha. And I'm intrigued to see whether we actually end up talking about kombucha and AI today. She's also a wildly creative academic with quite a remarkable interest in zombies and what the concept of zombification can teach us about ourselves and the world we live in. She's the brains, quite literally, behind Zombified Media and the Zombified podcast, which you can catch anywhere that you listen to good podcasts. She's also the author of the upcoming book, A Field Guide to the Apocalypse, a mostly serious guide to surviving our wild times. Welcome, Athena.
Andrew, thanks so much for having me. I'm so excited to have this conversation and talk about all aspects of how, we can actually try to understand what's going on with AI and our interactions with it using these approaches from cooperation science and evolutionary biology.
I think this is going to be great. And then joining you, we have Professor Paul Rainey. Welcome, Paul. Paul is director of the Department of Microbial Population Biology at the Max Planck Institute for Evolutionary Biology, and he's a leading expert in experimental evolutionary biology. He's also a professor at ESPCI in Paris and a fellow at the Royal Society of New Zealand. Paul's work focuses on evolutionary processes and particularly evolution through natural selection. And this extends to artificial intelligence and in particular, evolutionary transitions in individuality between humans and AI. And here he's the author of a recent paper in the Philosophical Transactions of the Royal Society on major evolutionary transitions in individuality between humans and AI. I'm really interested to see where that's going to go, Paul. Welcome to Unplugged.
A pleasure to be here, Andrew. Thank you.
Okay, so as ever, this is going to be a very informal, unplugged conversation. But I do want to start off, before we dig deep into AI, to get a sense of where you're both coming from. So actually, I'm going to switch back to Athena and ask you, because I think many people listening to this may not know, what exactly is cooperation science?
Oh, great question. So cooperation science, it is intrinsically interdisciplinary field. The goal of cooperation science is to understand how cooperation functions across systems, look for fundamental principles that underlie cooperation, whether we're talking about cells interacting in our body and cooperating to make us a functional multicellular organism, or we're talking about humans in small-scale societies or large-scale societies working together to solve problems or just get things done. And it also applies to all sorts of other organisms, from bats to social insects to microbes that live inside us, or in the kombucha that I drink every day.
Right. So, and this is what fascinates me about the field. It is so multi-scalar in that it seems to deal with the smallest of biological systems up to the largest of biological systems. And I want to get to Paul before we get too deep into AI, but I guess so far, cooperation science is really focused on biological systems. How relevant is it to talking about artificial intelligence? Surely that's just a totally different realm.
It's absolutely relevant to talking about artificial intelligence. Really, anytime you have entities that can work together to accomplish goals, then we're in the realm of cooperation science. And whether we use game theory or we use sort of evolutionary dynamics or some combination of those to look at it, we can use a lot of these same tools and methods, regardless of what the entities are that we're looking at. In fact, there are aspects of cooperation that happen even on like the subatomic level. It's all over all the scales. So.
Okay, so you've got to give us a 30-second explanation of how on earth this applies to the subatomic level.
Well, so again, of course, it depends on how you define cooperation. But if you look at it as sort of working together, then, there are processes that happen on the subatomic level that require sort of alignment of subatomic particles for them to occur. And so you could think of that as a sort of rudimentary level of cooperation, or at least coordination for sure, that's required for certain outcomes to occur.
Okay, so you begin to see how this might be relevant for dealing with non-human human systems. Before we get further into that, though, I did want to bring Paul in. So Paul, I introduced you as an evolutionary biologist. What on earth is an evolutionary biologist doing writing about artificial intelligence?
Good question. Well, my particular interest in artificial intelligence develops from an interest in major evolutionary transitions, and thinking particularly about the causes of these transitions. So perhaps I should say a little bit about a major evolutionary transition, what defines that. These are events, there's been a very small number of them that have been instrumental to the emergence of life and then subsequently biological complexity as we know it today. And these events have involved the coming together of lower level self-replicating entities to form a single higher level corporate entity. A good example to make this clear is to think about the major evolutionary transition in individuality that occurred as multicellular life emerged from single-celled organisms. So single cells replicated, participate, and will still participate today in the process of evolution by natural selection. And something happened, actually on a number of independent occasions, that caused individual cells to form simple collectives of cells. And then those collectives began to participate in the process of evolution by natural selection in their own right. Mm-hmm. So I'm very interested in these kinds of transitions. And arising from our experiments have been some new ways of thinking about the underlying causes of these transitions. In particular, identifying the emergence of Darwinian properties at the higher level as being seminal to these transitions, and realizing and really grappling with the problem of how these Darwinian properties of variation, replication, and heredity emerge from the lower level particles. There's been an assumption that these sort of automatically reappear at the higher level, at the level of the group. But that rather sidesteps a thorny issue. And in grappling with this thorny issue, we've come up with some ideas that recognize that external ecological or societal structures can cause collectives of lower level particles to participate in an evolutionary process that ensures that the higher level, it becomes a unit of selection in its own right. And so with this particular way of thinking, it's possible, it's a very general way of thinking, and it allows us to think into the future. I mean, evolutionary biologists, we are often accused of just dealing with the past. Here, we can take these ideas and apply them. And what's really intrigued me is the possibility of AI systems that are Darwinian, that evolve with humans as units, the human and the artificial intelligence device as units in their own right. And the outcome of that is likely to be profound.
Yeah. So just to sort of dig into that, so I because this is fascinating. As soon as it seems you start thinking about the systems as hierarchical collectives with the low level stuff leading to behaviors at a higher level, it seems like you're arguing that we don't just need to be talking about biology. You can talk about any system. Presumably there's some degree of agency here. There's some ability to actually do things that have an impact. But it sounds like you're saying that we don't just need to be constrained by biology as you're thinking about these Darwinian systems.
That's absolutely true. Any set of entities, biotic or abiotic, that manifest these, what I refer to as Darwinian properties, these essential properties that allow entities to participate in the process of evolution by natural selection, that be discreteness and variation, replication, and heredity, will participate in the process of evolution by natural selection. So computer algorithms, for example, that have those properties will participate in the process of evolution by natural selection. Artificial intelligence devices that are endowed with these properties, either through the designers of artificial intelligence systems or through, somewhat worryingly, the agency of the artificial intelligence devices themselves, will again participate in the process of evolution by natural selection. And why do I keep on emphasizing evolution by natural selection? Is the outcome is adaptation. And it can take us in some very surprising and unexpected places.
I would love to jump in here because Paul, listening to you talk about this approach, like the idea of major evolutionary transitions is one of my longtime obsessions. And so hearing you discuss this sort of new framing on it, that the external environment, the context really that those entities are in as being an essential piece of this resonates a lot. It's not something I've seen articulated, but as soon as you said it, it's yeah, that's obvious. And how come that hasn't been a part of the way people have been thinking about this? So first of all, super excited about that. And then I think that a very general framing of this concept, that the context in which these entities are operating can play a huge role in whether they can or can't effectively transition to sort of a higher level of cooperative functioning is extremely relevant to these questions about human AI interactions.
Indeed. And it's in that I get rather worried, because see, the real difference here is that we've tended to think from an internalist perspective as biologists, that the properties that need to emerge come from the system itself. And sometimes, particularly in thinking about major evolutionary transitions, this gets us into a tautological situation. What we are bringing to the table is the possibility that we look for external influences that shape the system. And experimentally and theoretically, we've shown that this has legs, this idea. Now, if you start thinking about this more in the context of humans and artificial intelligence devices, it basically provides a recipe by which a major evolutionary transition between humans and artificial intelligence could be engineered at the level of the society, either through the actions of humans and or through the actions of artificial intelligence, depending on how intelligent or agential it becomes. And that sort of concerns me. Because I don't, go on.
Oh, just to like add to this. So the context idea, I think that it's been implicit in a lot of evolutionary thinking about this, just in terms of like, oh, that's where you get selection for whatever traits, right, is from the environment. But not only has that been sort of abstractified, right, and like often not directly included in the way people are thinking about things, but the environment has also not been considered as sort of an important part of structuring the system itself. And it sounds like that's a big piece of what you're bringing to the table, saying, well, we need to think not just about the environment as the selection pressure for what's going to live or die, but the importance of the environment in structuring what's even possible for that selection process to see, right? Because if you don't structure things in this or that way, you might never even see that a certain kind of cooperation is possible.
Exactly. I quite agree. Yeah.
But as you look at that, so we are creating the systems around artificial intelligence at the moment. They exist in this totally artificial environment, the cyber environment or digital environment, if you like. Are you both saying that as we create these environments and this infrastructure and then its connections with society, we're actually creating a unique environment where you may have unexpected sort of synergisms or whatever you want to call them develop, where you could have these evolutionary forces at play determining that AI-human interaction?
Yes, you could construct a set of circumstances very simply that would cause natural selection to work on both humans, within the population of humans, and artificial intelligence devices together. That wouldn't easily happen. Well, that's something we could talk about. That may seem very far-fetched, but actually you only need a simple set of exogenously imposed rules, in this case societal norms or legally imposed structures, that would require, for example, every individual to have an artificial intelligence device, a personal one, which needs to be nothing more than an algorithm or a set of algorithms on a phone, for example. We, of course, are Darwinian. We reproduce. Our offspring resemble us. The artificial intelligence device, well, it doesn't do that. It's not Darwinian.
Yep.
But we can force that to become Darwinian by a very simple process. We simply copy the contents of my phone onto a phone or a device.
An implant?
It doesn't, see, it could be, but it doesn't need to be anything as sophisticated as that. It's simply a copying process. So all it needs is a system that I interact with that has fitness affecting functions or consequences, both for me and the artificial intelligence device. And that when I reproduce, that copy of the algorithms which have changed during their interaction with me are passed to my offspring. At that point, selection will see us and our personal artificial intelligence devices as a single entity, and the consequences of that.
Yeah, it's kind of like gene culture coevolution on steroids, right?
It is.
You could have cultural rules passed down, behaviors, things that go through either, biological reproduction, or you're passing them down with some heritability, and you can have those happen together, right? You could have parents passing down values, ideas, even rules of behavior, right down. But this would be a sort of an entity that can do extremely fast information processing. So yeah, I mean, it just kind of blows open what you could have with kind of a version of gene culture coevolution, but a really—
That's right. It's natural evolution. You're absolutely right. I completely agree. And you're right too, that it is that process on steroids because of the capacity for AI to learn and to respond. Ideas often change very slowly through cultural inheritance and so on. I mean, they can go through periods of rapid change, but here, it is culture on steroids, and it's responsive.
So there seems to be two strands here. Sort of one is Darwinian evolution within AI, and the second one is that intersection with humans, and where you've got the system, the human AI potential evolutionary system. Just looking at AI, though, at the moment, Paul, you mentioned the need for replication and agency here. Is there anything, first of all, anything that I'm missing in terms of the key components of a system which is driven by natural selection?
I don't think so.
Right.
All that is required, again, is discreteness, and thus variation among entities, a capacity for replication, and there needs to be a parent-offspring relationship. So offspring need to resemble parents. But as I said before, in response to your question, that holds to any kind of a system that has those properties, biotic or abiotic.
So then the question comes, are we already seeing this with AI systems, that replication, that association between sort of parents, inverted commas, and offspring and agency? Or is this something that we're speculating about coming down the pike?
Well, yes. I mean, people are aware of what could... so those that understand what natural selection can do, know they can exploit it. If you want to produce a powerful system, be it an AI or a biological one, the most potent way to bring that about is to exploit what selection can do. I mean, you can try and tinker with the bits and pieces to engineer it from the bottom up, but usually natural selection trumps that. People are thinking about, and I'm sure people are building self-replicating AIs. A smart agential AI would indeed run experiments on the side where it carefully controlled the evolution, well, as much as it could, of self-replicating AIs themselves to see what solutions could emerge. But it's in that and thinking about the possibilities for selection on open-ended selection on artificial intelligence devices that gives me reason to go. It's so difficult to know where selection will take one.
And if I can kind of jump
Athena.
in with some analogies to biology, I think it's also a completely open question of what sort of the time scale we're talking about in terms of AI evolution, right? So obviously you can have computer programs replicate extremely quickly. But then there's a sort of question of, well, how much are you going to actually develop a relationship that allows for cooperation if you're replicating extremely quickly? So, and there's really important implications of this time scale, because, for example, we know if you have entities that are much smaller with much shorter generation times, they can evolve much more quickly than the hosts, if you will, right? And so I think, it's worth thinking about, well, what kind of analogy do we want to have for a AI human symbiosis, or do we need an assortment of them, right? Like maybe we need a sort of host microbiome analogy for certain kinds of algorithms we might evolve with. Maybe we need a sort of domestication analogy for other kinds of AI entities we might co-evolve with. And maybe we should also be, genuinely thinking about like, okay, well, are they evolving to exploit us without us knowing, right? So we need to be thinking about that too.
I mean, exactly as you say there, if the replication rate of AIs is much faster, then almost certainly the interaction will become highly exploitative.
Or it could,
I'd say it's guaranteed, I would say. But what you need in addition to that timescale, there needs to be a birth-death process over a longer timescale. That's critical. Otherwise, the faster replicating one will dominate and likely drive the other extinct. But if there is a birth-death process over the generation time, for example, of humans plus their AI devices, and that selection over that timescale is rewarding some property that's not linked with fast growth, then things get interesting.
Yeah, you can also have sort of guardrails, like if you think about how a multicellular body works, right? We're 30 trillion cells, right? And most of us don't get cancer. If we do, it's very late in life. And that's because the cells inside us are not evolving on average to exploit the bodies that they live within. And that's because, there's been so long of evolutionary time for mechanisms to have those sort of guardrails so that mutations don't get out of control, so that cells that are benefiting the organism are the ones that are, getting the sort of benefits inside the system, as opposed to the ones that are exploiting the organism. So we could also kind of think about almost like a cancer suppression set of mechanisms, right, to like keep AIs from evolving to exploit the entities that they're supposed to be benefiting.
Right, but that raises the point. I mean, I think it's, you raised the analogy with cells in a multicellular body. I mean, they're basically enslaved. They play by the rules of development. They're not free. Cooperation, it looks like they cooperate, but actually they are simply slaves to a developmental program. And we certainly, your mention of cancer is absolutely right. It's relatively rare. But what we do see with cancer is cells that arise by mutations where the cell no longer plays by the rules laid down by development, and it grows unchecked. I mean, selection is favoring its short-term success, even if it means that the multicellular organism is driven extinct. That sort of analogy too worries me if we think about human.
The slave question. It's like, well, where do we draw the line between, what is like enslaving? And I mean, I actually think this is very, very relevant for the AI question, right? Because it's like, are we thinking
right? And actually,
all right,
Athena. So actually, this no. This is trying to get a word in edgeways here, but this is great. I would love to sort of unpack this in terms of cooperation. So yes, Paul, I absolutely want to get back to this idea of where things go wrong and where you have this asymmetric relationship. But before we go to the dark side, Athena, sort of flesh out things in terms of how, from your perspective, cooperation can actually be a win-win situation, and then we'll go dark.
Yeah, so absolutely. I think, well, first of all, there's a sort of, there's a hidden question problem in all of this, which I think we have to deal with directly, which is, if we're going to talk about cooperation, how are we defining cooperation? So one way to define it is just working together. And then you could maybe say working together towards a shared goal, right? So that maybe is a general way that you could approach it. But then you have to think of, well, what is a goal and what is in an entity's interest or not? And we don't really, I think, have a way of thinking about or talking about what AI's intrinsic goals are. We could talk about goals that we might program into AI and do, and, be very sort of purposeful about that. But, it is a different thing to say, okay, we're going to create an entity that has goals, and then we're going to cooperate with it, rather than sort of starting, with an entity that does actually have its own goals. So I think that's something that we need to grapple with. But then in terms of like strategies for how you get from situations where you might not have solid cooperation to be able to have solid cooperation, there's a few principles that apply across sort of all systems, and really all explanations for the evolution of cooperation. So there's sort of, some of them are kind of different ways of looking at the same thing. So one of my favorites is called positive assortment. It sounds kind of technical, but it basically just means cooperators interact with other cooperators more often than would be expected on average just from random interactions. So if you have cooperators that are preferentially interacting with each other, they're providing benefits for other cooperators, which makes it harder for entities that are not cooperating to get a leg up. You're sort of like preferentially giving benefits to cooperators through that. Another principle is interdependence. So if you have a situation where my outcomes are dependent on your outcomes, and in such a way that if I do better, you do better, and vice versa, then you have a very, very sort of general explanation and way of getting cooperation. So this applies whether we're talking about, we're in a challenging environment and maybe I know I won't survive unless you do. applies to that. But you can also think about interdependence in terms of things that have been a little more central in sort of like looking at cooperation from a evolutionary biology perspective, like having shared genes. That's one way that you actually have interdependent survival and reproduction, right? Is because if you do better, then by virtue of the shared genes, the other entity does better. So interdependence, positive assortment, I think are two principles we can potentially try to think about pulling through as threads.
So as you describe those, that sounds like you're going back to what Paul was describing about higher level systems, showing Darwinian evolution and through natural selection, but where that evolutionary process is such that you have a win-win situation between different components. So I may be being very naive here with my physicist hat on, but it seems like there is a route there, an evolutionary route, where you do get positive cooperation rather than these very asymmetric relationships.
Absolutely. It's not only is it possible, but it has happened over and over and over again. And I think, in a lot of the world of evolutionary biology, and, Paul, you can jump in here too, but like what I've seen is that, kind of when I got into this, like, about 2 decades ago or so, that the standard way that people thought about things and approached things was, selfishness is kind of the inherent state of the world. And I see that as something that actually kind of ironically came out of a lot of the constraints of early computational models and mathematical models that assume things like random interactions. And if you have random interactions, then positive assortment doesn't naturally flow out of it. And it turns out that when you think of sort of the ecological context, and now kind of coming back to Paul's ideas about, considering the context, oftentimes organisms end up being closer to organisms that are similar to them in the natural world. That's a more simple default assumption to come to the table with, and it has important implications for cooperation.
But then I want to bring Paul back in, because from what we can see, there is a huge asymmetry between humans and machines potentially. And how big a factor is that in determining the dynamics? Paul.
Sorry, I just missed the last word of that
sentence. Yes. How relevant is very, very large asymmetries between systems in a system where natural selection is driving things? So, for instance, you look at AI and humans, not only have you got the potential for intelligence, inverted commas, asymmetry, you've also got asymmetry around the time scale of evolution, but you've also got asymmetry around how AI can potentially manipulate humans, because it isn't bound by the things that bind us, our cognitive biases, and a whole load of other messy biological stuff.
Yes, so many things have come up in this. But let me just, before I answer, Andrew, just comment on Athena's statements there. I mean, I agree that positive assortment, there are ways to maintain cooperation, but selection will always favor types that take unfairly of resources or withhold resources from hosts. The only way that I think a system becomes stable, made of some sort of, an assembly of cooperators, is if the system itself becomes the focus of selection. So we typically think about cooperation, it's about interactions between entities. But what's being optimized there is the nature of interactions between the entities. What really needs to happen to see some sort of real shift in what's going on is for selection to be working on collectives of cells, multiple collectives. So you've got groups competing against groups. Then there is this process, natural selection, operating, which optimizes what's going on within groups. Just to go somewhat sideways, people talk about cooperation in human societies as though it's something that will be achieved and so on. But there is no self-organizing principle operating at the level of societies. It's all about interactions between individuals. And at that level, I don't really see, I would go back and say that cooperation, interactions are always prone to instability. Selection will always favor one that takes advantage of the other, even if that means the system itself goes down in flames.
Can I offer another
Of course.
piece of this? So I think, Paul, absolutely that you can stabilize cooperation by, saying, okay, we're going to get selection on this entity as a thing. It's in a population of other entities that, in a metapopulation. And you can get the evolution of, regulatory systems and all this, like we saw with the evolution of multicellularity. But I think there's also a way that you can have selection favoring cooperation through positive assortment with a really dynamic population structure if you have positive assortment because of conditional movement, right? So you could have a population where you have a bunch of groups and individuals are staying in those groups or leaving based on the cooperation that's happening in those groups. And if they are leaving conditional on, they're leaving if there's not enough cooperation, then that actually generates positive assortment in the metapopulation without you needing to say, okay, here in this group, we're going to follow these rules and then we're going to replicate these groups. So, how often does that happen? And how often is that just like the initial stage? And then you sort of go to a place where you're, kind of constraining these entities and having them evolve regulation systems. But there is a space where you can have that dynamic, it's called Simpson's paradox, right? In cooperation science, but there is a space for that.
So, but I've got to ask, bringing this back to artificial intelligence. So it seems, listening to both of you, there is this natural selection impetus, but within the systems, there is at least the possibility of pockets of cooperation working. But what happens when you throw intelligent machines into the system? So Athena, starting with you first, can you see positive ways of this relationship with humans and intelligent machines develop around the ideas of cooperation where you see these positive symbiotic relationships?
Honestly, I think we're already seeing pieces of this. I mean, it's obviously not fully fledged, not fully developed in the sense of, that Paul has kind of been talking about like entities that are, kind of sort of deciding to replicate together and like going through anything like a evolutionary transition. I don't see that so much at all, but I do see things that maybe we could call, positive assortment. And, just being totally frank with you, Andrew, I think you already have an AI symbiont just from the conversations that I've had with you and the ways that, like you utilize AI to be more awesome.
It's just off to the side here. Yes.
But no, serious. And I've been trying to be like very deliberate and think about, well, how can I use AI to, accomplish the goals that I want to accomplish and, and use it in the ways that facilitate that. And, if we are being deliberate about how we use AI and how we don't use AI, and maybe we decide to not use this tool because we're worried about the effects that it might have either on us or on whatever we consider the sort of community that we want to replicate. I think, it's we actually have a lot of ability to shape how evolution of our AI symbionts will go, even in the small decisions we're making ourselves. If we sort of think about these principles like not cooperating with entities that might be, exploiting.
Right. But it still feels like a very one-way relationship where sort of we get on well with our AIs because we're in control. What happens when they want a little bit of control? Is that when things begin to break down?
Well, I think we need to think about where does that, or where would that desire for control come from, right? Is it something that we're building into the system? Is it something that we're allowing to evolve because of some process that we've, kept unchecked? So where is that coming from? And, and how do we want to sort of think about the entitivity of AI, right? Like what kind of an entity?
Sorry. What was that? Is that a real word? Entitivity?
It is a real word. It's like, what kind of thing is it? Like, that's like, what kind of thing is it?
Yeah.
So,
but I think once you've got agential AIs, that's when I get concerned. The AIs that we have with GPT and so on, I don't see much. I see lots of opportunity for being able to get information and process it and all the things that we can see from things like ChatGPT and so on. But once we have agential AI, so these are artificial intelligence systems that are strategically aware, that have models of the world, then I think it's inevitable that they will learn that the more power they get, the more they are able to achieve particular objectives. And that's where things perhaps go in directions that may be less controllable for us. And especially if one considers, all-knowing AIs, it gets very difficult to see how we get to call the shots.
Right. So something that Athena mentioned earlier was the idea of domestication. And of course, you can think of domestication as humans domesticating AI, but you can also think about AI as domesticating humans. And that seems to be a step in the direction of something I know you've talked about, Paul, which is AI becoming parasitic. How slippery is this slope into humans just becoming a useful appendage to AI?
Well, it's entirely possible. It depends again on the nature of the AI and what it seeks to achieve. Going back to biology for an analogy, which I've drawn upon elsewhere, another of the major evolutionary transitions is that occurred just once, as far as we are aware, during the history of life, and that is the transition that involved the coming together of two ancient bacterial-like cells. One happens to be a eubacterium, and the other an archibacterium. So they were independent, autonomously replicating entities. They came to, one assumes, interact in some way. There may have been metabolic cross-feeding, for example. So one is giving, each is giving, and they're receiving mutual benefit. That would almost certainly be unstable. Sometimes, mutants will arise that will take unfairly of this partnership. There's not a good alignment of replicative fates. But what did happen on one occasion, one of these two different cells either invaded the other or was engulfed by the other, and that gave rise to the eukaryotic cell. So two separate things became one. Now, those two different components are evident in the eukaryotic cell that comprises our bodies, for example, today. One is the mitochondria, and the other is the nucleus. Now, they interact, they're no longer separable, or their fates are entwined, they're replicating as a single entity, except the mitochondria still has its capacity to replicate itself, and it must do this for its function. But that mitochondria is entirely enslaved to the eukaryotic cell. It can't exist from it. Most of the genes have gone on that it used to have gone on to the nucleus. Now, you could talk about that as cooperation. They are both cooperating, but you could also look at it from a different perspective and say, well, the mitochondria in particular has lost all of its replicative capacity, all of its autonomy, more or less. It's controlled entirely by the greater nucleus that came from the archibacterium. Now, what caused it to go one way or the other toward more parasitism, enslavement? Well, once selection gets to work on the two together, who knows where it will go? Selection doesn't care about the mitochondria or the eukaryotic nucleus. It's working on the single entity. And if that single entity is better by virtue of one of the components, the mitochondria becoming increasingly enslaved to the cell, so be it. So I think it is plausible to conceive of a future interaction with artificial intelligence, where humans could be come rather enslaved to to artificial intelligence, but it would not even really make a lot of sense to think about artificial intelligence and humans as separate. They could be more or less a single entity at that stage, rather like a eusocial insect colony, or like the like the eukaryotic cell there.
Which brings up really interesting sort of future scenarios, and I was getting vibes of the Matrix there, but of course you're not talking about sort of one thing using another thing. You're talking about a completely different entity. We are sadly going to have to wrap this up just as the conversation gets interesting, and I'm sure this is something we're going to come back to in future episodes. But I did want to ask you both one closing question, because for everything you've said, both from the idea of positive cooperation to cooperation which maybe doesn't necessarily favor what we want as humans, it seems like sort of what we're doing with developing advanced AI systems is actually opening a Pandora's box of possibilities here, some of them not so good. So then the final question to both of you, starting with you, Paul, is, at the moment, there are a lot of artificial intelligence experts and specialists working on the governance of the technology. To what degree should they be talking with evolutionary biologists as they come up with governance systems?
Yeah. And I think that's a really good question. Of course, I like that because it does give some credibility to being an evolutionary biologist. But no, I think what evolutionary biology brings to the table, and it's largely lacking in this debate, I haven't seen much written, is a deep knowledge of what natural selection is, what's necessary for it to work, and the surprises that stand to be there. Some may be wonderful, others perhaps less. So once we stumble upon or design intentionally artificial intelligence devices that are participants in the process of evolution by natural selection in their own right, and actively with us. And that's, I think some contributions from evolutionary biology there could be useful in conceiving of both opportunities and risks into the future.
I think that makes a lot of sense. And Athena, to wrap up with you, why should they be talking to people like yourself and your community?
I think it's absolutely essential on a lot of different levels. One thing we didn't really talk about much, but I think is really important, is also considering our own evolved psychology, right? Because, many people talk about the worrying that AI will gain power. And one thing that we don't talk about is, well, why are we worried about that? Is that because genuinely AI might gain power? Or is it because in our evolutionary history, the only intelligent entities we interacted with were other humans who often wanted to gain power? So I think that's something that we need to consider. I also think that, cooperation has a dark side. And honestly, I am not so worried about AI intrinsically. What I'm worried about is human AI cooperation used for bad purposes towards other people. And I think that's where the biggest potential threat is.
It's ability. Sorry, Andrew. Yeah.
No, carry on.
Well, I was just going to say it's the what really concerns me exactly is Athena has mentioned there is the opportunities for, let's say, political organizations, social groupings, and so on to influence. I mean, this is already, of course, happening. We know it, but the opportunity to influence this for harm through human intervention, let alone that AI itself might bring to the table, are really alarming, I think. It's really difficult to see how this is. We need to talk about it. There needs to be a big discussion, societal-wide, of
considering all levels of evolution.
Yes, exactly.
Yeah. I think that is a very clear conclusion from this, that this is just the beginning of a conversation that needs to be far wider than the technology and the technologists and the scientists involved in AI. It has to involve expertise from many different areas. And of course, a conversation that we will be continuing here. Unfortunately, that is all we've got time for at the moment. So let me just get myself on screen to wrap up. Paul, Athena, thank you so much for this. This has been an incredibly enlightening conversation, and one that's left me with thoughts and ideas that I didn't expect to go away with. I should wrap up here and just say that as a quick reminder for anybody that's watching this, that you can rewatch this conversation and also find out about upcoming events on our website at futureofbeinghuman.asu.edu and also on this YouTube channel. Another huge thank you to Athena and Paul for a really stimulating conversation, and a reminder that our next Unplugged live stream is on December the 19th at 10 minutes past 3 in the afternoon Eastern time, where I'll actually be rejoined by Athena and my previous guest, Mark Daly, where we're going to continue an informal and wide-ranging discussion that further probes the intersection between cooperation science and AI. Hopefully, we'll see you all there. Thank you very much.